yesterday, so that's why we had some funky kind of stuff going on. Alrighty, so we're doing implicit differentiation, and when we take the derivative, we take the derivative of every variable. The derivative of every constant is 0. So I had a number of people that when they got to implicit differentiation, they said, if I want to know what dy dx is, what I'm going to do is I'm going to take the derivative of every variable that's in this implicit differentiation. So if I take the derivative of this, I treat it just like I use the power rule, which means this exponent is 1. 1 times 2 is 2. This will go down to 0. And then I can write that as dx over dx. You can choose to do that, but if you understand every time you take the derivative of x with respect to x, you get 1, you can skip it. Over here I'm going to have the same thing, and I'm going to have the derivative of 3y as being just 3 times dy dx. Will I get that every time I have a y? The answer is yes. Here I have a constant, so I get 0. So this becomes 2 plus 3 times dy dx. And dy dx would equal a negative 2/3. Which it should be because that's the slope of that line. If I look at this one, this is going to become dy dx minus 2x. I'll write dx over dx here is equal to 0. So I'm going to have dy dx is equal to 2x. Where it's really helpful is on the back side. Here it is. This is a circle. I have a circle that looks like this. And I have a point here. This point here is 0, 5. This point here is 5, 0. This point here is 0, negative 5. And this is negative 5, 0. You're supposed to know that. That seem reasonable? Then right here I have a point, 3, 4. 3 squared is 9, 4 squared is 16, 9 plus 16 is 25. And so I have a tangent line that goes through there. What do I know about it? That it's negative. If I were have you to do it the old way, you would have to say that y squared equals 25 minus x squared. And y equals plus or minus, you got to remember that plus or minus, 25 minus x squared. Which you could write like this. Correct? And it's complicated. Would you agree with that, to take that derivative, to figure out dy dx? Well, this is nice if we do it using implicit differentiation. I'm not going to do it explicitly right here. I'm going to leave it like this, and I'm going to take the derivative of x squared, get 2x. I'm going to write dx over dx. If you choose not to, that's fine. The dx over dx is going to be 1 anyway. I'm going to get 2y, so I treat it just like I do x. The only difference is I'm going to be multiplying that by dy dx. And this equals 0 because it's a constant. So now I have 2y dy dx is equal to a negative 2x. This became 1. So that means dy dx is going to equal a negative 2x over 2y, which is a negative x over y. This derivative looks a lot simpler than the derivative I would get from that. But what do I need to figure out the slope of the tangent line? I also need to know y. Well, if you look at the point 3 comma 4, x is 3, y is 4, I'm going to get the slope of that tangent line to be a negative 3/4 by plugging 3 into x and 4 into y. Are we kind of getting the hang of it? Yes, ma'am.
So was the 3/4 just a given? You didn't have to do anything to find it?
All I did was plug 3 in for x and 4 into y.
Okay. But it was on the circle, right?
Yeah, I picked a point that I knew was on the circle 3, 4 because 3 squared plus 4 squared is 25.
Okay.
I grew up knowing the 3, 4, 5 triangle. That was a requirement in Kruger welding at the age of 9. I asked my dad where it came from. He said that pi guy, which I found out later was Pythagoras. And then I found out he couldn't say Pythagoras because his tongue had not been clipped. He was tongue-tied. You know what tongue-tied is?
Yeah.
Okay. And since you asked me a question, I'm going to ask you a question. Okay. Can you read this for me?
X, Y.
What does it mean?
X times Y.
Okay. Right, Aaron? So how would you go about doing that? What rule do you have to invoke because she said x times y? The product rule. Okay. Do you have a particular way you do the product rule? Which do you want to take first, the derivative of x or the derivative of y?
The derivative of x.
Okay, so what is the derivative of x? 1. So it's going to be 1 times y. Would you agree? Plus, you've taken the derivative of x, so I don't need to do that. You need to take the derivative of y, and that's going to become what?
So
1, I agree. 1 times what other thing? I need to have 1 times dy over dx. This variable over dx. This, I suppose you could say, is dx over dx. And that's going to equal what? 0. So this is going to be y plus x times dy dx. So that means dy dx equals what, Aaron?
negative y over x.
A negative y over x. So I would need both the x portion of the point and the y portion of the point to figure out the slope. Okay? Lillian, we have 1, 2, 3, 4, 5 terms. Okay? You take the derivative of one of those terms. You tell me which one you're going to take the derivative of.
Negative 5x to the 5th.
You're going to take that one? No, that's fine, that's fine. Okay, I just want to make sure I heard you right. Negative 5x to the 5th. Okay, so I'm going to have an equals. Oops, I'm not going to write that answer down. What is the derivative of that?
Negative 25x to the 4th.
Just like you did before. Will you put the dx over dx, or will you skip that part? Personally.
I skip it.
Pardon?
I skip it.
You skip it because it's 1 every single time, right? Okay, Becca. 1, 2, 3, 4 left. Which one do you want to take the derivative of?
Negative 3y.
The negative 3y. Okay, what are you going to get?
Negative 3 times dy over dx.
Perfect. Okay. That's y the first, correct? 1 times 3 is, or 1 times a negative 3 is a negative 3. That goes y the 0. And because it's a variable, I have to have dy over dx. You're next. You have 3 to choose from. Y to the third. Okay, what do you think the derivative is? I'm going to write a plus here.
3y squared.
Yep.
dy dx over dx.
Perfect. I'll make, is that, can everybody see that okay? I think that's hard to see. I'm going to make that a little bigger. Ethan?
Derivative of 17 is 0.
Yeah, I would have done that right away too. I was surprised. Weren't you surprised that one? It's kind of like when you play a game and there's a certain spot I want. I'm just going, really? People aren't. You know, it's there. Madeline, this one.
4y to the third times 2y over x.
Perfect. All right, Austin, we have a problem. We have 1, 2, 3 dy dx's. We can only have one. Have an idea how to solve that problem? Not sure? Okay. Natalie, do you?
Can you factor?
You can. You got to do one thing first. You are right. There's one thing I do first.
The 25 is 4th on the other side.
Yes, I would do that too. I call that the non-dy dx term. Okay? And now you're going to factor out the dy dx. Is that correct? Okay. So I'm going to have parentheses. Is that right? And I'm going to have 1, 2, 3 terms in there.
Yeah.
And what are those 3 terms?
4y cubed, 3y squared,
Minus 3. Okay, very good. Is that making sense, Austin? Okay. And then what are you going to do? Well, I'll take you, yeah. And remember, I want dy dx by itself.
Divide by 4y cubed plus 3y squared.
Yeah, divide by that whole quantity, correct? So dy dx is going to be 25x to the 4th over 4y cubed plus 3y squared minus 3. So again, I need both x and y to figure out the slope of the tangent line. Would you agree with that? So it's just not x this time. I need the entire point that I would plug in there to figure out the slope. Are we okay with that? All right, so we have this miserable thing. Allison, you want the right side or you want the left side?
right side.
The right side. Okay, so I'm going to look at this right side. Will you read the right side for me?
Negative 54 times x times y.
Will you say it louder for me?
Negative 54x
Negative 54x
times y.
times y. You said the word times, correct? So that means we didn't need to do the what?
Product rule.
Okay, let's do the product rule. What are you going to get?
Negative 54x times 1. 1 times negative 54.
Well, I got to take, okay, you took the derivative of y, correct?
Yeah.
So I do agree it's 1, but then because it's a variable, I have to multiply it by. I'm taking the derivative of y, correct? And so if you take a look at when all these people took the derivative of every term that had y in it, they attached to dy dx, correct?
Over dx.
Okay.
That should be a negative 54, not a 54x.
Okay? And now you're going to have plus, because it's the product rule.
Yep.
And you're going to have what?
Negative, well, 1 times, no, sorry, y times negative 54.
So can I write that as a minus 54y?
Yes.
Correct?
Yeah.
And for the people that want to, you could write dx over dx. If that helps you to remember to do dy over dx, do that. And over here I'm going to have a negative 54x dy over dx. So the right side looks like that. Nick, get us started on the left side. This looks like it's out of focus to me. I don't know if that's better or not. Okay? You got the chain rule in here because you got parentheses with a power on the outside. That's how I identify that I got the chain rule. Whenever I have parentheses, I'm thinking I got the chain rule. Okay? What if it was this? Are you stuck a little bit?
Yeah.
Okay, what if I would have had this? Do you see this?
Yeah.
How would you start?
You do 4 times 3.
You would do the 4 times the 3. That's what you're going to do on this one. The only difference is this is a y squared. And we'll figure out what to do when we get to that y squared. Okay? So you're going to take the 3 times the 4
Yeah.
and get what?
12 times.
And then this stuff in here stays the same. And then the power is going to be reduced by 1, correct?
Yeah.
And this is going to be what?
Squared.
Squared. Now we got to come in here and take the derivative. Correct?
Yeah.
Okay, it's going to be parentheses because there's going to be 2 things in there.
3x squared.
3x squared, perfect. Plus
2y dy dx.
perfect. 2y dy dx. So when Karsh was doing his problem, he said, "This is a hard problem." I said, "No. The one that my students will do tomorrow is a hard problem. And that's this one, Adam." Okay? So we have a dy dx over here and a dy dx over here, correct? And we can't have 2 of them. So, Addison, what do you think we should do besides make my handwriting look neater? You kind of want to do that, don't you? Like multiply all that stuff out? Do what? I think multiplying through is a good idea, but I don't want to multiply that out because it's going to get really, really bad. So I'm going to take all of this times that term. And would you agree I get 36x squared? That's 12 times 3. 12 times 3x squared. And then I'm going to leave this like this. Because I'm just going to put numbers in there anyway, right? And then I'm going to have plus, and I'm going to have 12 times 2, which is 24, y, and then I'm going to leave this x cubed plus x squared squared alone, and then I have dy dx, and then it's equal to this. Now, I've got a term here. I'm going to use a different color. I've got a dy dx term here. And I got a dy dx term. This whole thing is a term because this and this are combined by multiplication, correct? Yes, sir.
How did you get x to the 3rd plus 1?
So I took this right here, multiplied it by that term. That's where you see it here. Then I took it and multiplied it by that term, and that's what you see here. I did not do a good job there. So I have this outside of parentheses in which I'm adding, right? And we have the distributive property. It doesn't matter what's out there. I multiply it by both terms. So I took the 12 times the 2 and got 24. Here's the y from here. I inserted this in between here and I just rearranged it so it looked like that because the dy dx is at the end. So now what I'm going to do is I'm going to move this one, I'll make this smaller. I'm going to move this term over to here, and I'm going to move that term over here. Why is this term moving? There's no dy dx with it, is there? So I'm going to have 54x dy dx plus 24y y cubed plus y squared squared dy dx equals a negative 36x squared x cubed plus y squared, that quantity squared, minus 54y. Natalie, anything you see I made a mistake on or something I need to clarify?
I'm just trying to think through.
Okay. So now I have a dy dx here and a dy dx here. I'm going to factor out the dy dx. And I'm going to have 54x plus 24y times x cubed plus y squared squared equals all of this. So dy dx equals a negative 36x squared x cubed plus y squared squared minus 54y over 54x plus 24y times x cubed plus y squared squared. What's my point? Negative 1, 2? So that gives me a negative 36. A negative 1 cubed is what? Negative 1. What's 2 squared? 4. What's a negative 1 plus 4? What's 3 squared? 9. Minus 54 times 2. What's 54 times 2? 108. So this would be a negative 54 plus, we already figured this out to be 9, right? Correct? 24 times 2 is 48. 48 times 9, I might need help on this. Let's see if I can figure this out. $432, is that right? What? Okay, you know what I did? I took 9 times 50. That's 450, because 9 times 5 is 45. And I know for each 9, I'm 2 points over. So I subtracted 18. That's how I do my math. That's how I keep from drowning when I swim. Okay, so this is a negative 100. No, it's not. It's a negative 324, isn't it? I don't have a calculator up here, but well, I do, but I'm not using it. Is it 324? Negative 324 minus 108 is a negative 432. And 432 minus 54, subtraction's always a little bit more of a pain. So 32, 18, is it 382? Oh, 378. Then that 78. I don't know what that simplifies to. What? Must be something over 7, correct? What is it over 7? Negative 8 sevenths. I like a negative 8 sevenths. Whew, that was terrible. Okay, that'll never be on a quiz. Okay, this one will be though. This one will be Musab. Take the derivative of this whole thing right here. Oh, what 2 things do we need for an equation of a tangent line, by the way? Guess what? We already got a point. Slope. 11 times. Right, Noah? 11 times.
Is that both classes or just ours?
That's total, both classes. Okay? So, to figure out the slope, you got to take the derivative for me. What are you going to get when you take the derivative of the first term?
3x squared.
3x squared. Plus, what's the derivative of this?
8y.
Times what? What do you absolutely need? Over dx. You're going to get that every time you have y. Okay? There is a dx over dx here. Does everybody understand that? Equals what?
So 0.
Yeah, kind of sad the 3 died. So what does that mean that dy dx is? And our point is negative 1, 1, correct? So what's the slope of my tangent line? No, it's got to be a number. What are you going to put in for x? Well, you're going to square it, correct? Over 8. That's my slope. So the equation of my tangent line is equal to what? Which is? Times, in parentheses, it'd be x minus a negative 1. Yep. There's a 1 here, correct? If I put that negative 1 in here, I get 0, correct? Negative 3/8 times 0 is 0, and I want it to be 1, so it better be what kind of here? Is it plus or minus? Plus. Okay, that's the slope of my tangent line. This has got to be a number. I do not want to put this into here. Okay, there better be a number here. And I get that by plugging these values into there to get this number, which goes here. Yes, sir.
So on number 6, if
Yeah.
like just somehow had that wrong, then you just started by dividing both sides by xy. And then
here,
Yeah.
divided by xy.
Yeah.
So then I gotta do the quotient rule over here with the product rule on the bottom. I wouldn't. No. But I suppose you could. There might be somebody out there that would like to do that. All right.